Hello friends, in this video we will learn the Gauss-Seidel method. So this Gauss-Seidel method we will see here with the help of one numerical. So numerical statement is given the linear equation solved by Gauss-Seidel method. Three simultaneous equations are given, means three unknowns are there in terms of their x, y and z. So first equation is 4x plus y plus z is equals to 5. Second equation is x plus 6y plus 2z is equals to 19. Third equation is minus x minus 2y minus 5z is equals to 10. So we have to solve these three simultaneous equation with the help of Gauss-Seidel method. So solution. So first we will give the naming to the each equation. That is first equation 4x plus y plus z is equals to 5, equation number 1. Then second equation x plus 6y plus 2z is equals to 19, equation number 2. And third equation is minus x minus 2y minus 5z is equals to 10, equation number 3. So after giving the naming, then from equation 1 we have to find the equation of x. So how to find this? So all these terms except the x keep at right side, and whatever coefficient of x is divided to this term. So equation 4 becomes the x is equals to 5 minus y minus z divided by 4. This is equation number 4. Then from equation 2 find the value of y. So y is equals to 19 minus 2z minus x divided by 6 is equals this is the equation number 5. And from equation 3 find the value of z is equals to 10 minus x minus 2y divided by 5. This is equation number 6. So once you get the equation 4, 5, 6 or equation of x, y, z, then find the first iteration. So for first iteration put y is equals to 0 and z is equals to 0 in equation 4. Then equation 4 becomes 5 minus y minus z upon 4 is equals to 5. Y is 0 here and z is 0. Put the value of this upon 4 is equals to, after simplification we'll get the 1.25. So this x value 1.25 and z is equals to 0. Put this in equation 5. So equation 5 is 19 minus 2z minus x upon 6 is equals to, z is here put 0 and x whatever we calculate the value of x is 1.25. Put in this equation and after simplification we'll get the 2.9583. Then this x and y value whatever we calculate put in the equation number 6, then we'll get the value of z. So x is 1.25 and y is 2.9583. So equation 6 is 10 minus x minus 2y upon 5 is equals to 10 minus 1.25 minus 2 into 2.9583 upon 5. After simplification we'll get the minus 3.433. So this is the iteration first. Then go for the iteration 2. How much iteration will do here? The difference between the previous iteration and next iteration is not much more. So whatever we calculate the iterations, then we can see here the difference between the values of x and y and z. So iteration 2 is put the value of y and z whatever we calculate in the iteration 1, then put in the equation number 4. So equation 4 becomes 5 minus 2.9583 minus 3.433 upon 4. After simplification we'll get the 1.3687. Then put the value of this x whatever we calculate in the iteration 2 and previous z value iteration 1. From iteration 1 put in the equation number 5, then we'll get the 19 minus 2 into minus 3.433 upon minus 1.3687 upon 6. After simplification we'll get the 4.083. Then the x and y value put in the equation number 6. Equation 6 becomes the 10 minus 1.3687 minus 2 into 4.083 upon 5 is equals to minus 3.9069. So this is the iteration number 2. So if we see the difference between the first iteration xyz value and second iteration xyz value, then x value is 1.25, then in iteration 2 x value is 1.3687. So y value is 2.9583 and in iteration 2 y value is 4.083. Then z value is minus 3.433 and in iteration 2 z value is minus 3.9069. So difference is here more. So go for the iteration number 3. So iteration 3 becomes put the value of y and z from iteration 2 in the equation number 4. So equation 4 becomes 5 minus 4.083 minus 3.9069 upon 4 is equals to, or after simplification we'll get the 1.2060. Then put the value of this iteration 3 x value and z value from iteration 2 in the equation 5. Then equation 5 becomes 19 minus 2 into minus 3.9069 minus 1.2060 upon 6 is equals to 4.2680. Then x and y value from iteration 3 put in the equation number 6. Then equation 6 becomes 10 minus 1.2060 minus 2 into 4.2680 upon 5. After simplification we will get the minus 3.9484. Then go for the iteration 4. Then iteration 4, put the value of y and z from the iteration 3 in the equation number 4. So equation 4 becomes 5 minus 4.2680 minus 3.9484 upon 4 is equals to 1.1701. Then put this value of x from iteration 4 and z from the iteration 3 in the equation number 5. So equation 5 becomes 19 minus 2 into minus 3.9484 minus 1.1701 upon 6. So after simplification we will get the 4.2878. So put the value of x and y from iteration 4 in equation number 6. Then equation 6 becomes 10 minus 1.1701 minus 2 into 4.2878 upon 5 is equals to minus 3.9491. So if you see here the difference between the previous x value and this new iteration number 4 x value difference, that is 1.2060 of x value from iteration 3 and from iteration 4, that is x value is 1.1701. Then y value, compare the 4.2680 here 4.2878. Then z value minus 3.9484. Then from iteration 4 z value is minus 3.9491. So here again we will get the difference of this error in the iteration 3 and iteration 4. Then go for the iteration 5. Then iteration 5, put the value of y and z from iteration 4 in the equation number 4. So equation 4 becomes 5 minus 4.2878 minus 3.9491 upon 4. Simplify it, we will get the 1.1653. Then put the value of this x from iteration 5 and z value from iteration 4 in equation number 5. So equation number 5 becomes 19 minus 2 into minus 3.9491 minus 1.1653 upon 6. After simplification we will get the 4.2888. So put the value of x and y from iteration 5 in equation number 6. So equation number 6 becomes 10 minus 1.1653 minus 2 into 4.2888 upon 5 equals to minus 3.9486. Then go for the iteration 5. So iteration 6. So iteration 6, put the value of y and z from iteration 5 in equation number 4. So equation number 4 becomes 5 minus 4.288 minus 3.9486 upon 4 is equals to 1.1649. So put the value of this x value from iteration 6 and z value from iteration 5 in equation number 5. So equation 5 becomes 19 minus 2 into minus 3.9486 minus 1.1649 upon 6 is equals to 4.2887. Then put the value of x and y from iteration 6 in equation number 6. Then equation 6 becomes z is equals to 10 minus 1.1649 minus 2 into 4.2887 upon 5 is equals to minus 3.9485. Now compare this iteration 5 values of xyz and iteration 6 xyz value. So here the x value is 1.1653 and from iteration 6 1.1649. So if you see the difference between these is, or error is in between them is 0.004. Then compare the value of y 4.2888 and from iteration 6 4.2887. So error is here 0.0001. Then the z value is minus 3.9486 and from iteration 6 is minus 3.9485. So here error is also 0.0001. So this error is less. So we can conclude here the final value of x, y and z unknowns. Here the x is equals to 1.1649, then y is 4.2887 and z is minus 3.9485. So in this way we can do the iterations and find the unknowns using the Gauss-Seidel method. Thanks for watching. We will meet